Hello, I'm Frances Joseph, and I'm going to be speaking today about textility and fibrosity, living material systems. Excuse the slightly complicated heading, but we will discuss those complicated terms. I'm a professor of material futures at Auckland University of Technology, and I also have my own company, Intra-Action Initiatives, which is focused on working with community and industry to create greater awareness about more sustainable material practices and relationships. And I also work with companies and organisations to support the development and use of alternative materials and new material economies in New Zealand. So the talk today is really focused on issues of materiality, the material world that we all live in and are made up of, and interconnection through making. As the audience is mostly artists and designers and creatives, I've tried to focus it around, I suppose, areas of materiality and making in terms of creative practice, but I also do touch on scientific work and I suppose areas where design has been commercialised. An alternative heading for this talk, if the European Union hadn't already come up with it, was How Matter Comes to Matter. And why I love that heading and wished I had invented it is because it's both about the fact that material things are important, they do matter, but also it's got a lovely sense of circularity to it, that matter can be regenerated or matter doesn't disappear. So there's a cyclic sense of matter becoming matter and regenerating. So this focus is really today about rethinking material systems. And that's a big shift that's happening. It's been called the material turn in sort of philosophical circles, but it's this idea of shifting from closed linear systems like supply chains or construction systems, which are important in industries, but have always got this sense of it's really only from when you get hold of the material to when you sell it or someone buys it from you, and then afterwards we don't need to worry about it. So moving from a linear system to circular systems where the life of things is considered beyond their consumption and things are regenerated or reused or repurposed. And the other big shift is from interactive systems which are based on cause and effect, and where the elements in an interactive system maintain a level of independence and separateness. There's a reaction and an action and a reaction, but it's within a closed system. And the shift is really towards thinking about interactive systems. The word was proposed by the physicist Karen Barad, and she talks about a dynamism of forces in which all designated things are constantly exchanging, diffracting, influencing, and working inseparably. So talking about an interconnection with things, and we'll talk a little bit more about physics later on as well, because that's been really important. Ideas of quantum physics are sort of grounding a lot of this way of thinking about things and materials. So today we're going to talk through some key ideas and terms. I'm going to then talk through a couple of new strategies or approaches in terms of working with materials. And throughout, I will be introducing some related projects, creative projects generally. And so we're talking about this shift from what Christopher Chase has called the ecological, that is where man is at humans, a person is at the centre, and everything sort of relates to them, to ecological, to extending out and connecting with our environment and our life world. It's not surprising that we have had that ego-logical system where humankind has sort of been at the center of the world. If we think back to classical Greek and also Christian theologies, which is represented in this image of the great chain of being, you'll see there that there is a hierarchy of being. And so at the bottom is plants. It's interesting, their taxonomy. It goes plants, animals, fish and insects, birds, then humans, and then we have angels, and then we have the boss angels, and then we have the deity at the top. Obviously, in a sort of more recent diagram like this, we probably, well, a lot of people mightn't have the angels and the deity, but the humans certainly at the top of the visible life forms chain. A really important other way of thinking about this hasn't just come from new ideas with philosophy and thinking about and ecology and thinking about the problems we have with our relationship with the material world, but there are some other really important and distinctive independent strategies. And Te Ao Māori, the concept of whakapapa as kinship and connection between the spiritual world, the natural world, and people, that idea of kinship and relationship rather than a taxonomy and a hierarchy is really important. And I think we're very lucky in New Zealand that we've been able to have a discourse that has brought, certainly there's an intersection of these ideas, recognising that their origin points are independent from one another. For myself, I suppose the framework that's been really important to me has been new materialism, which is a sort of a shift in thinking, an interdisciplinary and theoretically and politically committed field of inquiry. So it's got a philosophical grounding, but it's also very much geared towards action and change. And it emerged as an interdisciplinary area, it emerged from areas of feminism, philosophy, science studies, environmental studies, and cultural theory around the beginning of the 21st century. And it really challenged notions of matter as a sort of inert substance, something that we mine and we use and we discard, to considering matter as an active force that's both co-produced, so matter doesn't just come into being by itself, it's produced through relationships and interactions with things, and it's also co-productive in conditioning and enabling social worlds and expression, human life and experience. Do you want to read more about new materialism? There's a fabulous European Union project called New Materialism, if you want to find out more about it, but that's just giving you a very quick overview. Because I work with textiles, I think sometimes people, when I'm using terms like textility and fibrosity, I'm going to do a presentation on weaving or knitting or felting. And while those techniques are important in my own practice, what I'm really wanting to do today is to think about these in a more metaphorical way. And as human beings, we all use metaphors. And so perhaps coming to an understanding of some of these concepts through textile metaphors, textile structures is a better way of explaining, coming to terms with them. So clearly with fibre, we've got that notion of threads and filaments and things that might link or tangle together or be woven together. And there's two particular concepts related to this that have been important to me. One of them is Deleuze and Guattari's idea of the rhizome, which they developed quite a long time ago in terms of sort of media. But rather than thinking of hierarchical tree structures, which is the way that a lot of Western knowledge systems have been built, you have the branch, and then if you think about disciplines, you have the branch, and then you have these different sub-disciplines branching off and other little networks of branches and things. And it's a hierarchical system. The trunk is more important than the little branches at the end. So they propose this idea of the rhizome or the rhizomic networks. If you think about rhizomes, you might think about a ginger plant, if we've got gardeners in our group today, with the root develops rootlets and then it grows another root, or flax is another plant that has a rhizomic structure. So those are quite useful plant metaphors, if you like, and also that link in with fibres as well, because there are obviously a lot of plant-based fibres. The other idea that links in with this idea of fibrosity and filaments and interconnection is the idea of entanglement, which comes from quantum physics. And entanglement is when two particles, such as a pair of photons or a pair of electrons, they remain connected across distances. So they don't behave, they look like they're physically separated, but they don't behave like that. They develop other behaviors, either between two particles or a group of particles. And that was a phenomena that was really surprising. And Albert Einstein talked about it as, I love this quote, spooky action at a distance. From this idea of quantum physics, they've developed quantum mechanics, there's quantum computing, there's a lot of new technologies which have developed working with these principles of this sort of, but I suppose in a more philosophical sense, really, we're talking about or recognizing that there is this interconnection between things where things are interconnected in the world of, in the world of theoretical physics. They've actually found and developed models that recognize this. And this idea of entanglement has been, so it's really, that's fundamental to new materialism, that sort of recognizing that principle, but also it's been picked up in other areas. So we have ideas of cultural entanglement, for example, with expatriate artists who might be working both within an explicit culture, but also another culture that's informing their work. And so this idea of explicit connections as well as hidden connections. So the idea of entanglement's been picked up in a number of different areas. The other concept that's in the title is textility, and again, not referring specifically to a textile, but more to an idea put forward by anthropologist Tim Ingold, where he writes, and he's writing very much about making in this particular paper, the textility of making. He writes about the forms of things arising within fields and force flows of materials. It's by intervening in these force fields and following the lines of flow that practitioners make things. In this view, making's a practice of weaving, in which practitioners bind their own pathways or lines of becoming into the texture of material flows comprising the life world. So textility, he says, by emphasizing materiality and these forces and interplays between materials, centers on the movement and processes of negotiation between materials and human action. So I think it's a beautiful paper. It's online. You can access it. It's open source. But I think that's a really interesting idea, this process of negotiation between materials and human actions, rather than, and he talks about this as well, the older way of thinking where, in a sense, human willed or forced the material to become something. And so the idea of textility then, and this interweaving of forces and material qualities and human engagement and negotiation is important as well. Linked into that is the idea of making with, and this was introduced by Donna Haraway in her fabulous book Staying with the Trouble. But again, coming back to these ideas of ecocentric and egocentric, moving from this idea of autopoiesis or self-making, not just about your own, not so much self-identity, but more about the human self and things revolving around human beings, to this idea of making with something, rather than making from, rather than extracting and making from, a process of actually making, creating, collaborating with. And that's been really important in my own creative practice. This is a photograph of a work called Salt Sleeve, and it was a collaborative project called Phenomenal Dress that was a collaboration between Karakari Beach and my dear colleague Miranda Smitheram and myself. And we worked for 2 years really out at the beach, developing artifacts and performances and Intra-Actions. So this particular work was done with cloth and salt and evaporation, and working with both materials and phenomena that were very prevalent at Kari. And so with this, we talked about collaboration being reoriented within a context where the ecosystem was the primary collaborator, and was this idea of repositioning human and more than human relationships. So Anna Singh has written a beautiful book called Mushroom at the End of the World, and we took a quote from her when we were talking about this work. Staying alive for every species requires livable collaborations, and that collaboration means working across difference. And so I thought we did a lot of work for this, and we've published quite a few papers about it, but this was one of my favorites, this lovely morphing of the branch and the artwork and the human arm at beautiful, beautiful Kari Beach. Moving into, rather than talking about terms and concepts, talking about some new strategies. And so one of the strategies that I've been working with has been with bio-based materials. What are bio-based materials? So materials made from substances derived from biomass, that's living or once living organisms. Often, nowadays, we're really trying to focus on bio-based materials that use renewable resources like food and agricultural waste rather than food sources. And so thinking about waste sources, and these require less resource-intense production and processing. And bio-based materials are often biodegradable, but not all of them are. So this is another sort of slightly tricky issue around what's biodegradable, what's compostable, how does it get composted, a whole lot of questions like that we'll talk a little bit more about. Why would we want to work with bio-based materials? One of the things is about lessening environmental impact. And so, those current linear models, which really talk about cradle to grave rather than cradle to cradle, they are, the sources of carbon emissions, waste and pollution. And particularly in the textile industry, relies on industrial agriculture, non-renewable petrochemicals for synthetic fabrics, and then chemical dyes, tanning and finishing agents, is both chemically and energy intensive processing. The textile sector, according to a European Union report, was the third largest source of water degradation and land use in 2020. This is the effect, particularly of fast fashion and mass consumption of clothing, particularly. And bio-based fabrication can play a critical role in making a transition to a sustainable circular economy, which is why there's been a very big EU initiatives in terms of bio-based materials. I just think this, very briefly, this image of the poster produced by the European Environmental Agency, which actually has mapped the carbon footprint of one person in the EU in 2020. And so the textile consumption used it was the equivalent to 400 square meters of land, 9 cubic meters of water, and 391 kilograms of raw materials, which caused a carbon footprint of about 270 kilograms per person per year. And so we've really got to rethink our systems, particularly the fashion system, but also other systems where synthetics we're using synthetic materials. Another reason to think about bio-based materials is localization. Obviously, if you're using local resources, local materials, local production systems, you're reducing transport costs, but also you're investing in local economies. And this is extremely important. We noticed this with the pandemic, and when suddenly we couldn't import things. And that was very interesting to see where certain industries started to actually rethink their global supply chains and think about the importance of having the opportunity to source things locally. Another reason why bio-based materials is about addressing the plastics problem. We know the problem with fossil fuel-based plastics. It's an urgent environmental issue. And plastics from fossil fuels are only just over 100 years old. And I have to say this here, I'm not anti-plastic, because I think plastics are an amazing material. The big problem with plastics is how we've used them, how we've abused them. And this is evident so plastics revolutionized all sorts of aspects of modern life, medicine, and the fact that you could use disposables rather than having to sterilize everything for hours. The food industry, so that food didn't spoil so quickly. Transport. There's a whole lot of areas where plastics have been, just caused incredible changes in the way that we live. But a lot of it's about how we don't really think about the impact of plastics. And production increased from 2.3 million tonnes in 1950 to 448 million tonnes by 2015, and production's expected to double by 2050. Now, the other thing that terrified me when I read this was more than half of all the plastics ever made have been produced since 2000. So our consumption of plastic, our use of plastic has just skyrocketed, and then only 9% of plastics are currently recycled. So there's a big issue there, obviously. And the impact of plastics, we know they break down to microplastics. The microplastics are found everywhere, including babies in utero. They found microplastics, and millions of animals and birds are killed every year by plastics. We've all seen those images of seabirds washed up on the beach and their tummies and seals filled with plastic, but also microplastics, which we really still don't understand the full effects of microplastics on our health and well-being. What are the solutions to the plastic problems? So one, obviously, preventing plastic from entering the waste stream, having better management systems, and then the 3 Re's, the rethinking. So thinking about designing with plastic and whether things can be made so they can be taken apart and recycled rather than, we all know this, they could be recycled or they could be repaired. At the moment, with the sort of mass consumption of things, that's gone out the window. So there's a big movement particularly in product design, to think about designing things that can be recycled more easily. Reducing manufacturing of unnecessary single-use plastics and packaging. The thing that really annoys me is going into a hardware shop and having to buy, and I want 4 screws, and I have to buy a packet of 10, and it's wrapped in this plastic, vacuum form plastic that I have to cut open with scissors. It's just nuts. Anyway, and the other one is about reusing rather than trashing. But another strategy, another re-strategy, is replacing with new bio-based plastics. However, if we're talking about plastics, the first plastics weren't petroleum-based, they were bio-based plastics. Xylenite wasn't the first bio-based plastic, but it's a really good example because it was the first artificially made commercial plastic produced in the UK, and it was used for combs and brushes and mirrors and what they call fancy goods, buttons and all sorts of things, as well as used for insulation for wires and also for ceiling panels. You'll see from that photo that the brushes and things, they all imitate ivory. So actually, even from its sort of initial stages, the motivation for developing these bioplastics, these plastics, was a replacement for materials like ivory, which were just way too expensive. And also, of course, the impact on elephant populations. Not Not that that was an issue at that stage on people's minds. Xylenite was produced by treating cellulose, such as cotton lint or linen waste, with a nitrating acid. What is bioplastic? So it's a plastic made without petroleum, using biomass. It's usually composed of a biopolymer, so that's a molecular chain that comes from that food waste or agricultural waste source, a plasticizer and a solvent. Solvent's often water, although obviously in industrial bioplastics they might use other solvents as well. Bioplastics differ in the ways that they break down. So some are biodegradable. You will have seen plastic bags that says, yes, you can put me in your compost. That's a bioplastic bag that's compostable. But there are other forms of bioplastics like PET, which are only compostable in industrial composting facilities because they have to be heated up. This is where we get we get a problem with recycling plastics anyway, petroleum plastics and all the numbers and which ones can be recycled and not. But also we have a double problem because if the bioplastic goes into the petroleum plastic recycling, it causes problems. And then obviously if you put your non-compostable bioplastic in your compost bin, that's going to cause problems as well. So there's a lot that needs to happen with communication about both petroleum plastics and bioplastics so that people understand how to use them, what you can and can't do with different sorts of plastics. So PET, the PET plastic, there are some companies now that have product stewardship schemes where if they make something with PET that they will recycle it. And there's a whole group of 3D printers who recycle PET plastic as well. Sources of biomass, and this is really important, thinking about waste sources rather than food sources. So sources of biomass tend to fall into either carbohydrate-based, collagen-based, agar-based, or chitosan-based. And you can see there different examples that I've given for carbohydrate. So often it's things like sugarcane waste or cotton waste or wood waste in New Zealand, lignin, they do a lot of work with bioplastics, but also things like avocado seeds. Collagen, with the gelatin ones are pretty limited to animal meat waste products. Agar, seaweed, and again, there's a lot of work going on in this area, particularly with seaweed farming, because it's a great carbon soak, but also it grows so quickly and it produces really interesting bioplastics. And also chitosan, which is mostly prawn, crab, shells. But also they're doing work with looking at fungi like from wine yeast to produce chitosan as well. Some photos of me hand processing avocado pits to produce the starch, and you can see what a beautiful colour it makes. However, in Mexico, for example, there's a company that's turning the avocado seed waste into bioplastics as well. There's a link there. What's happening in the bioplastic space? There's a lot of scientific research, and I'm just for this quickly just giving you some New Zealand examples. So Scion, the big government research laboratory, has got a major initiative with bioplastics, particularly with lignin, with wood waste. They've also done some lovely work with, I just saw a project they've just done with zespri. You remember the zespri sort of sporks, those, what are they, knife and spoon, where you could cut the kiwi fruit and eat it with the spoon, that were made of plastic. They've actually developed with Scion a bioplastic made from the kiwi fruit skins, and they're now making those particular spoons that they export out of a bioplastic. Commercial applications, again, a lot starting to happen in this space, particularly with packaging, but also one New Zealand company that's really interesting because it's Keravos, which is made with waste wool and a bioplastic. And that's been, and it can be cast like a normal plastic can. It comes in pellets. And Torpedo 7 have used them to make their kakapau canoe, which again, they have a product stewardship system with those canoes, so that if at the end of life the company will recycle them. And also Victory Knives has done a collaboration with the Ironclad company in Australia, making knife handles out of Keravos. So that's a really interesting company to have a look at. But what's happening with artists and designers and makers working with bioplastics, and there's some very, very interesting work going on here. There's a lot of DIY publications. So Fab Lab in Barcelona runs a fabulous Fab Textiles Lab, and the Bioplastics Cookbook by Margaret Dunn came out of that, available online, and also sites like Instructables. For example, this one, Make Your Own Bioplastics, has been published by a group out of DIY Bio from Hong Kong. There's a lot of material online if you're interested in doing some home experiments with bioplastics. A project that I thought was very beautiful by Fiona Bell, Ella McQuaid, and Mirella Allister, called Cooking Sustainable Clothing, because a lot of these DIY bioplastics you do cook on the stove. And so they made handmade sustainable custom clothing using a product that they developed called Alganil, a DIY biotextile made from marine algae. So that's one example. And another one, probably one of my favourite projects, is Feel the Peel by Carlo Ratti Associati, which is an Italian design company. And they developed an experimental orange squeezer for Eni, which is the Italian energy group, which makes bioplastics out of orange peels and uses it to 3D print cups to drink the juice. So the oranges, you can see them coming down over this lovely circular sort of dome. The juice gets squeezed into a bioplastic cup. Then the peels and the cups go down into the sort of composter. That gets processed into a bioplastic, and off to the side they have a 3D printer which prints out the cups. Obviously it doesn't happen the same day as you put your cup in, but there's a whole circular system there, and a fabulous promotions piece in terms of getting people to think about circular systems, and also about becoming more familiar with bioplastics. Second strategy, briefly, is about living material systems. Those are self-organizing life forms that interact with their environment. A sort of pivotal work in this area, and there's a lot happening in the architectural space with regenerative architecture around these living material systems. But the project, the Silk Pavilion, that was developed by the Mediated Matter Group at MIT, led by Neri Oxman. And this was constructed using 3D printers. So they made a lattice shape, and then silkworms. And the silkworms spun their silk over the pavilion. And it was about exploring how 3D printers and silkworms the relationship between digital and biological fabrication. And they asked, how can humans collaborate with other species to create new materials and structures without depleting natural resources? In 2019, they made a second pavilion, and a lovely quote from there as well: the silkworms are not tools, they're collaborators, engineers and designers. I'm sorry I don't have a photo of that one, but there's plenty of links to that project. If you look up the Silk Pavilion or Neri Oxman, you'll find a lot published on that. Another material, or another set of biological collaborators, is with the kombucha leather, which is made from bacterial cellulose, and it produces a flexible biomaterial alternative made by nanofibrils spun by bacteria and yeast. So it's basically this: if you've made kombucha at home, it's the SCOBY that floats on top. The combination, the symbiotic culture of bacteria and yeast that floats on top of that causes the fermentation process that makes the kombucha drink. So when you're growing bacterial cellulose, you're not growing it for the drink, you're growing it for the SCOBY on top, the biological leather. So you can grow and buy your own SCOBY starter, and there's lots of, again, DIY resources with people making things out of the kombucha leather. There's a number of commercialized products as well. Clothing. Stella McCarthy's done a line of synthetic leather, bio leather garments using, and she's got a lot of patents around the processing of kombucha leather. But again, so Biofab Forum has produced a manual for growing bacterial leather kombucha, and Instructables has also got some, amongst a lot of other sites as well, if you want to do this. My example for this is one of my master's students, Claudine Nalisu, who's now going on to do her PhD, and she did a lovely project exploring bio-based materials as a method to create eco-friendly, sustainable art installations. So she was doing a lot of installations, particularly for festivals and for events. And she was getting very annoyed with and very concerned about the amount of waste that was being generated, because these works would come down and then basically they'd be put into landfill. Or a lot of them would be. And so she started experimenting with bio-based materials, and particularly with kombucha leather. So there's a lot of examples in her thesis, which is available online if people want it, to access it. But she also worked with examples like the silk one with silk fibres, where she grew the SCOBY up through the silk and then dried that out, and that it's actually far more radiant in real life. But a lot of different work with colouring, with dyeing, with how much shrinkage occurs, etc. And then another material that again, I've got another master's student, but also a lot of work happening in the space using mycelium, which is the root-like structure of fungus. And again, this is a good gardening metaphor for this one. And so the mycelium is often grown on agricultural or forestry waste products. A lot of the DIY mycelium projects work on shredded cardboard, but there's projects where companies are using wood waste and various organic sources like that. And so the mycelium itself is grown within the substrate and starts to form these sheets it's almost like a dense felted fabric. So there's a lot of creative work going on with this, and a lot of products that are coming to the market. The one that I've chosen to briefly introduce is a New Zealand one, which is Biofab, which is producing a beautiful beautiful replacement material for polystyrene, which is one of the worst plastics to think about recycling at all. And most of it ends up in landfill. So, but the Biofab is making packaging material out of mycelium, and they actually they'll cast the mycelium into shapes for particular products. And so we can do away with all of that, those bits of polystyrene when you open up a package that spill all over the place. So that's another great New Zealand initiative. And I think that is my presentation for now. I hope that in terms of your own work and interests, that you've found some ideas and projects and approaches inspiring. Here's a list of references, and you will have noted too that there were a number of links and things in the presentation. And there's my contact if you want to get in touch with me. Thank you very much.